So as promised, we're going to start out with those dosages based on weight. And we've looked at that first step of converting weight in pounds to kilograms. Did somebody have a question? Oops, okay. As I heard something coming over the network. We got some weird sound things going on today. Okay, so let's say that we have a patient who comes in at 110 pounds. We have a label that is saying we should give 12 micrograms per kilogram per hour. There are a couple of different ways we can approach this. First thing we're going to have to do no matter what is turn pounds into kilograms. We divide by 2.2, which gives us that 110 pounds is 50 kilograms. So now we can take that 50 kilograms and we can actually use dimensional analysis on it. Take 50 kilograms over 1. And we can leave the hours off here. We're going to remember that hours is our unit of time. But we're going to keep that separate for now. And we're going to use this relationship right here. 12 micrograms per kilogram. Now we have kilograms here, so kilograms need to go on bottom here. So 12 micrograms to 1 kilogram. Kilograms cancel out. 50 times 12 is 600 micrograms over 1 if you want to leave it that way. So that is saying 600 micrograms back to our unit of time per hour. Or if you want to look at it in a more familiar setting, 0.6 milligrams per hour. So let's look at a patient again who comes in with a weight of 160 pounds. And we have a label or a recommendation of 18, let's do this. I'm going to put it in as 150 micrograms per kilogram per 6 hours. Now again, I have to start out by changing my pounds into kilograms. So 160 divided by 2.2, 72.73 kilograms. Now in some applications on your dosage calculation test in the program, they will actually have you round to the nearest, just the nearest kilogram. Some they'll actually have you round to the nearest 10 kilograms or 5 kilograms for different things. We're going to keep it down to the 10th or 100th of a kilogram like this, just so that if you want to round it off later, you can. We're going to keep it precise. So our patient is 72.73 kilograms. Put that over 1, and we're going to use our dosage to convert that to, our recommendation to convert that to a dosage. Just like last time, we're going to keep the time off to the side and apply that later. So that's got to come back in here at the end. We're going to get rid of kilograms. What do we have related to kilograms? 150 micrograms. Yes, 150 micrograms to 1 kilogram. So the kilograms cancel out. So 72.73 times 150 is 10,909 909.1, whatever. 905 you have? Oh, if you put in so this is where it gets a little tricky as well. You'll notice I left it in my calculator and multiplied by 150. If you rounded it to 72.73 times 150, yes, 109. So it doesn't seem like it should make that big of a difference, but it does. So that's micrograms over 1. So now here, I'm not going to leave that as micrograms. I'm going to convert that to milligrams because you don't want to deal with 10,000 micrograms. That's going to be 10.91 milligrams. To go from micrograms to milligrams, remember milligrams, there's 1,000 milligrams in 1 gram. And 1 gram is 1,000,000 micrograms. So, if you work out the conversion, that means that 1 milligram is 1,000 micrograms. I always remember micro, from units to milli to micro, it's 1,000 each step. Does anybody struggle with that conversion between micro and milli? Because that is one you will see quite a bit. So it's either 1,000 or 3 decimal places. Now, what do we still have to remember here? 6 hours. That is per 6 hours. So let's say we have a patient that comes in at 80 pounds. We have a label that is recommending 0.2 milligrams per kilogram per 8 hours. And is showing 25 milligrams in 8 milliliters. So what are we going to administer to the patient? Well, obviously now we're looking at administering this dosage in milliliters. So again, our first step, as always, is convert our pounds. 80 divided by 2.2. 36.36 kilograms. So now we're going to take our weight, 36.36 kilograms, over 1, and we're going to use our dosage here to convert that. Kilograms on bottom, milligrams on top now. It's 0.2 milligrams per 1 kilogram. But we're not going to stop at milligrams. We're going to go to milliliters here. So I can put the next step on, milligrams to milliliters, our relationship, 25 milligrams to 8 milliliters. So the milligrams cancel out. So now what we have on top, 36.36. I'll go ahead and type it back in so we don't get the round off here. Times 0.2 times 8 is 58.17, 58.18 milliliters over 25. So we're going to divide by 25. That's 2.33 milliliters. What do we have to remember about that? Yeah, that's 2.33 milliliters. That is every 8 hours. Well, yeah, I'm going to leave it as 8 hours. In this case, the question just asked how many milliliters. So you found the milliliters and you had to specify the 8 hours. The question might ask, how many milliliters per day or how many milliliters per 6 hours. And we'll look at how to make that conversion in a little bit. But yeah, for now, for that one, and I should have said that. That's a good question. I should have stated that we're keeping the time frame better. Should have asked how many milliliters per 8 hours that we're going to administer. So have you guys try one. So we're going to have a 65-pound patient. Our recommendation is going to be 3 milligrams per kilogram per 6 hours. And it is 20 milligrams in 3 milliliters. So I want to know how many milliliters to administer every 6 hours. I'll give you a couple minutes. So first step, always divide by 2.2 to change our pounds into kilograms. Here's 29.54. 55, right? 55 kilograms. So 29.55 kilograms. We are going to 3 milligrams per 1 kilogram. Get rid of the kilograms. Milligrams to milliliters here. 20 milligrams and 3 milliliters. Cancels out. So now on top we've got 29.55 times 3 milliliters. Which gives us 265.95 milliliters. Over 1 times 1 times 20 is 20. So divide that by 20. This is 13.3 actually. Milliliters per 6 hours. How many of you had that? Good. The next step is to talk about dosages based on body surface area. And I should have pulled up the nomogram here, and I didn't. Got it sitting right here. One of the methods of finding body surface area is this nomogram. It's just a graphic tool that allows us to quickly combine height and weight to get a standard body surface area. So one of the methods to calculate body surface area, we need to know both the height and the weight, again, weight or mass, of the patient. So let's say that we have a patient who is, and generally when we're talking about body surface area, we're usually talking about body surface area of a child. So let's say we have a patient who is 4 feet 11 inches tall and 95 pounds. So first we got to convert 4 feet 11 inches into just feet, or into just inches, sorry. So 4 feet times 12 is 48 inches, plus the 11 inches is 59 inches. So we're comparing 59 inches and 95 pounds. So if we look on the nomogram here, we've got height over here and weight over here. And this is the body surface area. This box right here is totally different. It's just taking up space right now. We could take that whole box out of there and it does not affect the rest of this at all. So just ignore that piece for right now. So we had a height of 59 inches. So you can see this is inches here. So we're going to go down and find 59 is that mark right there. So there, that dot is 59 inches. And a weight of 95 pounds. So over here, pounds is on this side. 95 is right there. 95 pounds. Now what we have to do is we have to connect those two. So I'm just going to use a line on the computer here to do it. And I'm going to do some beef up that line a little bit to make it more visible for you. Make it red. There. So you can see it a little bit better. You got to adjust this end just a touch to put it right on the 95. Okay, so it connects 59 inches to 95 pounds. Now where it crosses this one here is the body surface area. Body surface area is always given in square meters, no matter what we're looking at. So here that is 1.3 and 1.4. So it looks like each of those is going to be 0.02 because there's 5 spaces. You can see that scale changes as we go up, by the way. The spacing is different. So here, let me go through finding that. We've talked about scales when we did syringes, but let's go through finding that. From 0.3 to 0.4, that's a difference of 0.1. And there are 5 spaces. So that means each space is 0.02 square meters. So that's 0.3. This would be 0.32, 0.34. Maybe it looks like between 0.34 and 0.36. I'd say that's 1.35 square meters. Is what that is saying. So this patient is going to list as 1.35 meters squared. Now that's approximate, obviously. We're going to go back and use that nomogram a bit more in a little bit, but there are formulas for finding body surface area. If you are given standard units, the body surface area in meters squared is equal to the square root of your height in inches times, well, not your height, the patient's height in inches times the patient's weight in pounds divided by 3,131. So for this patient, that would have been 59 times 95 divided by 3131. Most of your calculators allow you to put this in there all at once. So you do second square root. And now most of you, it would give you, when you do the square root symbol, it's going to give you an open parentheses. So you're just going to type in 59 times 95 divided by 3131. And most of you would have to then close the parentheses to tell the calculator that you're going all the way to the end of that to do the square root. Hit equals, and you get 1.337, so 1.34. So you can see here the nomogram, we said between 1.34 and 1.35, somewhere in there. So 1.35 is pretty darn close. Let's take a look at another example. Let's say we have a patient that has a height of 120 centimeters and a weight of 35 kilograms. So let's look at our nomogram. So look at 120 centimeters is right here. 120 is on this side. 35 kilograms is going to be right here. So I'm going to move my line. 120 and 35 over here. Now you see where it crosses this axis here. It looks like it's just below 1.1 or almost right on 1.1. Maybe 1.09, 1.08. So let's, for our guess here off the nomogram, it's really not a guess, but for our estimate off the nomogram, we're going to say 1.09 square meters. Up here, I gave you the formula if we had standard height and weight, so inches and pounds. If we are given our height and weight in metric units, the body surface area, still in square meters, is the square root of the height in centimeters, times, it would be mass, but we're still going to call it weight in kilograms, divided by 3,600. So for this patient, it'll be 120 times 35 over 3,600. So again, second square root, 120 times 35 divided by 3,600. And again, many of you would have to put closed parentheses at the end of that. Equals, I'm getting 1.08 meters squared. Consistently, I have found, by the way, that the nomogram gives you an answer just slightly higher than the formula for body surface area. But here, in both of these examples, we came out pretty darn close. 1.08 is our calculated, 1.09 is from the nomogram. So that's how the nomogram works. Now, obviously, you're not going to have if you have it on your computer screen and you use a line like that, great. Normally what you're doing is you have that printed or in a manual somewhere, and you're going to take the edge of a piece of paper or a ruler and line it up across there. I'm guessing, just because almost every time I've been into the clinic in the last several years, they've got their tablet PC in their lap. I'm guessing they've probably got a little program now where they just punch in the weight and height, and it spits out a body surface area if they need it. But anyway, we said this piece here was totally separate from everything else, and it is. It's just filling up space in the middle of this table. It could be put on a totally separate piece of paper and stand alone. But we had to have the space between here and here anyway to make this work, to make the line fit appropriately, so they just put it in here as a spacer. But what that is that is a quick reference for a child of normal height for weight. So what we're going to do is we're going to go back to these examples I just did. And we're going to see if this child is normal height, if these children are normal height to weight. So this was 5 foot or 59 inches and 95 pounds. So for 59 inches, or sorry, weight in pounds, 95 pounds. Well, this one doesn't go that high. So much for that one. What would it be for 90 pounds? It would top out at just over 1.3. This person was 1.35. So it's pretty accurate. This kid is pretty close to average height for weight. Now this one, of course, is in kilograms, 35 kilograms. We would do times 2.2, would be 77 pounds. So let's look them up, 77 pounds, and see if they come out close. So 77 pounds would be somewhere in here. That's looking between 1.1 and 1.2, between 1.15 actually and 1.2. So what, 1.17, 1.18, somewhere in there. Call it 1.17. This kid's actually, well, I would say under height for their weight. Because they're shorter, the formula gives a smaller body surface area. So if this is giving a larger body surface area than what we calculated from the formula, that is actually telling you that their weight is higher than what their height would allow. So they are overweight or above weight for their height. So we can do the same type of calculations. Let's say that we have let's just deal with a patient who is 4'3" and 60 pounds. A label that says to administer 20 milligrams per square meter of body surface area. So our first step here is going to be to figure out body surface area. Now at this point, I'm going to assume you guys can use the nomogram. So I'm going to scrap that. We're going to get rid of it. Does anybody have questions on how to use the nomogram? Just lining stuff up? Okay. I'm going to dump that so it's not clogging up my memory on the computer here quick. So let's find our body surface area using the formula. So first we got to put the height in all inches. So 4 times 12 is 48, plus 3 is 51. So this is 51 times 60 over, those are standard units, so it's 31. So second square root, 51 times 60 divided by 3131. 0.99 basically, square meters. Just like with our dosages based on weight, we have the square meters, and we're going to use our label to convert that into the dose. So we have 0.99 square meters over 1, and this is listed as, per square meter, 20 milligrams per square meter, per 1 square meter. So the square meters cancel out. 0.99 times 20 give us 19.8 milligrams. Any questions? So let's say we have a patient who's coming in at 110 centimeters and 30 kilograms. The label says "25 milligram per meter squared," and this is constituted at 5 milligrams and 2 milliliters. How many milliliters do you put in to administer? By the way, there usually is a time associated with these as well. This is usually either given as per day or per week. We're going to list this one as per day for right now. So go ahead in your notes, see if you can figure out how many milliliters to administer this patient per day. So our first step is to do our body surface area. 110 centimeters times 30 kilograms divided by 3,600. So second square root, 110 times 30 divided by 3,600. You get 0.96 square meters. So then it's the 0.96 square meters over 1. Square meters on bottom, so it's going to be 25 milligrams per square meter. So it's 0.96 times 25 is 24 milligrams. Now we wanted this in milliliters, so there'd be one more step. Milligrams, milliliters, there's 5 milligrams per 2 milliliters. So milligrams cancel out. 24 times 2 is 48 milliliters over 5 milligrams. That's going to give us 9.6 milliliters. Could have done this all in one row like I've been doing all the other problems, but I took a pause in the middle. How many of you came up with 9.6 milliliters per day? Anybody have questions on how we came up with that or anything we did there? Okay. The next step is to start talking about something called titrations. Titration allows us to alter dosages. The first and purest application of a titration is, let's say that you're given, so we have a patient who comes in at 110 pounds. And our label, so far what we've done in our examples, is our label has said so many milligrams per kilogram or micrograms per kilogram. Well, this time our label is going to say 25 micrograms to 30 micrograms per kilogram per hour. And this is constituted at 50 milligrams in 20 milliliters. And we want to know what is our range in milliliters per hour that we can administer to this patient. So obviously the first step, as always, when we're given pounds, is this has to become kilograms. 110 divided by 2.2 is 50 kilograms. So now we're going to start with 50 kilograms. And we're going to convert this now into a dose. However, we got to pick one, either the 25 or the 30. I will almost always pick the higher end, the maximum dose. The reason I would say that is we're going to do a titration to get the other end. So we're going to calculate one end using the methods we've talked about. Then we're going to use this titration technique to get the other end. If something goes wrong in that titration, I would much rather screw up the minimum dose than the maximum dose. Because that maximum dose, if you exceed the maximum dose, really bad things can happen. If you're under the minimum dose, the worst that can happen is the patient needs more treatment. So I'm going to use the maximum dose, the 30 micrograms per kilogram. Now I need to get to milliliters. The problem is I'm not linked micrograms to milliliters, I'm linked milligrams to milliliters. So I do have to make some sort of a conversion for that. Micrograms to milligrams, the relationship is 1 microgram. Milligrams. The milligram is the larger unit, so I'm going to give that 1. How many micrograms are in that 1 milligram? 1,000. 1,000 micrograms in that 1 milligram. So that puts us in milligrams. And next, I'm going to convert to milliliters. So milligrams on bottom, milliliters on top. 50 milligrams to 20 milliliters. And the milligrams are now gone. So what we have here, 50 times 30 times 1 times 20, is 30,000. Does that look right? Milliliters. On bottom, 1 times 1 times 1,000 times 50 is 50,000. We divide that out, we get 0.6. So that's 0.6 milliliters, and that was the maximum. That's the higher end. To get the lower end, we're going to use titration. So we're going to take our calculated dose, times a ratio. And on the bottom of that ratio, or that fraction, is going to be what we used before, the old dose. What's going to go on top is the new, the desired end. So what that means for this one, we're going to take the 0.6 milliliters, and we're going to multiply. We use the 30, that's going to go on bottom, and we're converting it to the 25. So this will be 0.6 times 25 divided by 30. So I can just simply do that. This number times the numerator divided by the denominator gives us 0.5. So that's saying the lower end of that range would be 0.5. So this dosage could be anywhere from 0.5 to 0.6 milliliters per hour. So that's one possible application of a titration. The other possible application is for times. Let's say we're looking at a patient who is, let's go 80 pounds. And our label says 3 to 4 milligrams per kilogram per 8 hours. And constituted as 5 milligrams in 4 milliliters. The doctor is ordering you to medicate 4 times a day. So how many hours between doses? 6 hours. We are still going to ignore the 8 hours for now. We are going to, as always, convert our weight from pounds to kilograms. So divide by 2.2. $36.36 kilograms. So we've got 36.36 kilograms over 1. Kilograms on bottom, milligrams on top. We're going to go to the maximum dose again, the 4 milligrams per 1 kilogram. And we're going to go ahead and convert milligrams to milliliters. It says 5 milligrams to 4 milliliters. So we're going to take 36.36 times 4 and times 4 again, giving us 581.76 on top milliliters. On bottom, 1 times 1 times 5 is 5. So I'm going to divide that out. 116.35. Now the problem is that 116.35 milliliters is per 8 hours. We want this per 6 hours. If we're doing a titration on time, it's going to be our dose times the old time on bottom, the new time on top. So this was 116.35 milliliters. 8 hours on bottom, 6 hours on top. So 116.35 times 6 divided by 8 is 87.26, we're going to call it. That is now milliliters per 6 hours. Well, that is the maximum dose. That's the highest dose. 87.26. Still got to do the minimum dose. So now we can do a titration on that. 87.26 times. We use the 4 and we're converting it to the 3. So it'll be 4 on bottom, 3 on top. So 87.26 times 3 divided by 4. 65.45. So this is saying 65.45 to 87.26 milliliters per 6 hours. One of the applications of these titrations is to deal with safe doses. So let's say that the doctor orders milliliters of Tylenol 3 every 4 hours. For a patient, it's 55 pounds. You look at the label, and the label says that it is 12 milligrams of codeine in 5 milliliters of solution, medication. You look it up in the reference, and you find that the safe dosage is 0.5 to 1.0 milligrams per kilogram per 4 hours. So we're going to work through this. The doctor ordered 12 milliliters of Tylenol 3. First thing we have to do is we have to look at the patient. Convert them into kilograms. 55 divided by 2.2 gives us 20 kilograms. Now we're going to take that 20 kilograms over 1. And again, I'm going to deal with the maximum, the 1.0. So 1.0 milligrams per kilogram. So the kilograms cancel out. Thank you. Want me to wait? Want me to wait till next week and talk to you about it before we grade it?
I appreciate it.
Okay. So the kilograms cancel out. Then I have 12 milligrams here in 5 milliliters. So the milligrams cancel out. So now I have 20 times 1.0 times 5 is 100 milliliters. 1 times 1 times 12 is 12. Which is going to give us what? 8.33 milliliters. That is per 4 hours. That's the maximum. The minimum, I take the 8.33 times, we had 1.0 is what we used, the minimum would be 0.5, it's going to give us 4.17 milliliters. So what we're getting here is a safe dose of 4.17 milliliters to 8.33 milliliters every 4 hours. The doctor's recommendation of 12 milliliters is excessive, not safe. Where these get a little more tricky is, let's say the doctor recommended that 12 hours. Let's redo this problem. Let's say the doctor recommended that over 6 hours instead of 4. So at 4 hours, it's not safe. It's over. What would it be at 6 hours? Well, now we're going to take this dose that we calculated as a safe dose, and we're going to do that titration. All we're really concerned about is the maximum dose at this point. 8.3. This is for 4 hours, and we're converting it to 6. So 8.33, that'd be times 6 divided by 4. It's going to give us 12.49, 12.50. That'd be per 6 hours now. So if that were 12 milliliters per 6 hours, that'd be just barely a safe dose, but it would be a safe dose. Okay, a lot for you guys to think about. Homework to look at, page 172 through 173. Page 178 through 179. Page 184. Page 188 to 190. And page 196 to 197. And this does conclude our dosage calculation portion of the unit. So next week will be dosage calculation test. I have it planned out so that all we are doing next week is the test, because I wanted to make sure we had 20 minutes at the beginning of the hour to review if you guys wanted to review. I realize this homework is kind of intense, so if you have questions on it, don't panic. We will have time to review or answer questions before or during the test. Now, if you still want to come in and start the test early, that is still okay. You can do that. I'll let you stop and listen to questions if you want to at the beginning of class. Okay, any questions?